CDD Kadhani from KK Wag Institute of Engineering Education and Research, Nasik, Maharashtra State, India. Today we will start with Unit 1 and the lecture is based on Introduction to Steel Structures. Now, whenever we want to study the steel structure, design of steel structure, we must try to understand what is a structural steel, its types, properties, and different products available in the markets, so that a structural engineer can properly utilize a different materials of different properties, or you can say composition, different shapes, and different as per the requirements of a design of a structure. So let us study first the structural steel products. So now these structural steels are classified into the following, that are the flat hot rolled products, plates, flat bars, sheets, and strips. Hot rolled sections, that is rolled shapes and hollow structural sections, bolts, welding electrodes, cold rolled shapes. Now, in case of hot rolled sections, there are different shapes available, and the number one is a W shapes, or it's also called as wide flange section. Here, the flange's width is wider as compared to regular I section. So here, this is S shapes, American standard beam, that is I beam. C shape, this is also called as a channel section. This is an angle section. L shapes, this is an equal angle section. This is unequal angle section. This is a T section, a structural T shape. These are the bars. They are rectangular, square, round, and there are flat plates. Now, as a structural engineer, we have to select a proper section as per the requirement or the force carried by different structural elements. So that's why we must study how this choice of section can be done at a particular stages of design. So here, governed by the choice of section is governed by the cross-sectional area, section modulus, and radius of area. These are the three criteria which governs the choice of the section. Now, in IS 808 and IS Handbook number 1 lists all the properties of different shapes of the structural steel sections. Here, similarly, number of companies like SAIL, Tata Steel, ISA Steel are publishing their catalogs of the different types of section produced by these companies. So with the help of these catalogs, one can understand the different sections, their properties, and suitable section can be chosen for particular structural steel applications. Next, in IS 1852 gives allowable rolling tolerances. That means it gives information regarding thickness, amount of flange, and wave warping, deviation of wave warping. In IS 800-2007, that is a limited design of steel structure code, there is no minimum thickness requirement. That means, I will repeat, IS 800-2007, there is no minimum thickness requirement as such mentioned in the specific code. However, better to use minimum thickness of 6 mm for the main members and 5 mm for secondary members exposed to the atmosphere, especially in coastal areas. Now let us learn about wide flange sections. These beams have flanges, especially these beams have flanges in which the flanges planes are nearly parallel. Whereas this is a standard section here this the bottom portion of the flange, wide flange, are parallel to each other, whereas these bottom portions are somewhat sloping towards wave. And here then they are connected by means of some certain root radius. Here there is a radius, here there is a radius or rounded. So these wide plane section, excellent sectional performance, high bending and buckling resistance, easy fabrication, no tapered washer while bolting. So the advantage of wide plane section as compared to standard I-beam section is that it has high bending, buckling resistance, and it does not require a tapered washer. Because a standard I-beam, tapered washer is necessary. So again, the wide flange beams are economical due to higher section modulus for the same weight. It's a very important parameter. Economical due to higher sectional modulus for the same weight. Now, by using different sections, one can produce different hybrid sections by combining variety of sections together as per the requirement, need, as per the choice. So these are the photographs of actual steel structure. See, first photograph shows you a tapered beam sections. These are main beams, tapered beams, and these are secondary beams. Whereas these tapered beams having provided this intermediate stiffness to prevent a local buckling of the webs. In a second photograph, it gives us information regarding castellated beams. Here, the standard rolled eye sections are cut in a automatic controlled welding machine such that these type of sections are produced. Those are called as castellated beams or castellated girders. And here the advantage of this section is that as the hole is provided in the web, the self-weight of the girder reduces. At the same time, the height of castellated girder is increased, so bending stiffness have increased. At the same time, the you may say the self-weight of the girder beam is reduced. Another one is the tubular sections. IS 1161 gives a brief information regarding tubular sections. Here is a photograph of a airport where number of tubular sections are used for vertical, horizontal, as well as the bifurcating members. Now IS 4923 gives us a brief information regarding hollow, square or rectangular sections. So here in this photograph, if you observe, these are parabolic hollow steel sections are provided to take the load of the roof of a McDonald's center, and look at the aesthetics provided by this section. At the same time, it gives a good appearance and aesthetics. Cold form sections. IS 801 gives the information regarding cold form sections. So cold form steel sections are made from light gauge steel strips 2 mm to 4 mm thick, 20 bg, 8 bg. Due to the possibility of local instability, lips are provided to give increased stiffness. So this channel section at this end, this is turned. Similarly, this channel section is turned here. Similarly, this Z section is turned here. Small portion, extended portion. These are nothing but lips. Due to that, instability, local instability of the section is prevented because they are very thinner sections. High performance steel. Now, as the name suggests, this is a steel where it will give you high strength, high ultimate strength, high yield strength. Here, high performance steels grades are HPS 485W was developed in USA during 1994. So what are the enhancements of this high performance steel as compared to the normal steel or common steel? So it has good reliability, toughness, corrosion resistance, ductility, fatigue and fire resistance, formidity and strength. All these are the enhancement as compared to the normal steel. 3 grades of HPS are available. They are HPS 345W, HPS 485W and HPS 690W. HPS 485W is widely used in a different or a variety of structures. So here the bridge is a HPS bridge. So the bridge in Tennessee is a 2-span continuous structure on a state route 53 over Martin Creek in Jackson County. And the specialty of the bridge is there is a 25% reduction in the weight and 16% in the cost. So here high performance steel has been used successfully now on many projects in several states or several countries. Stainless steel. Stainless steel developed in 20th century, and as all of you know, this is a rust resistance alloy steel, and it contains low carbon and about or greater than 10.5% chromium. So these are the grades of stainless steel. Now when you observe or compare the stress strain curves of a mild steel, this one, and a stress strain curve of a stainless steel, you will find that initially up to say 100 and 120 Newton per mm square stress they are matching, but after that or after increasing stress beyond this level, the stress resistance or strength of steel is increasing as compared to the mild steel. Here it reaches to highest level up to the tune of say 270 Newton per mm square, whereas mild steel reaches to the tune of 210 or 220. But after this, after 0.2% strain, the stress of a stainless steel slightly reduces, and again after this stage the stainless steel stress is a constant but is continuous deformation. That means after this yield point of stainless steel there is a continuous deformation without increase in a strength, whereas the mild steel strength increases above this level. Therefore you can say after a strain of 0.5%, the mild steel strength is higher than the strength of the strength of stainless steel is this one and mild steel graph is this one. So stainless steel graph is a regular graph, but after say 0.5% strain the stainless steel strength increases as compared to mild steel. Advantages of a steel as a structural material. So there are many advantages of structural materials, and number one is high strength, high ductility, uniformity, environment friendly. It's a versatile material, amenable for prefabrication. So these structural components can be prefabricated in the controlled environment in a factory and can be transported outside and they can be erected. Permanence, so they have got a good durability if they are maintained very well. Easy to repair and add additional structure. So additional structures can be bolted to existing structure, additional structure can be welded to existing structure, or additional story can be built to the initial storage. Least disturbance to community, fracture toughness, high fracture toughness, and it has got good, excellent elasticity as compared to the other materials. Steel has certain, or you can say few disadvantages. What are they? So first advantage is maintenance cost due to painting. This is disadvantage. Fireproofing costs. It requires fireproofing. Special paints are to be provided on the surface to protect from fires. Susceptibility buckling, reduction in strain due to fatigue loads. If there is a fatigue load, so there is a possibility of reduction in strain due to fatigue. So let's study now the types of steel structures. So there are various, in these diagrams you can observe various types of structures. Number one is a single bay beam. Here these are vertical columns and this is a rafter. The joints may be pinned or rigid. Similarly, this is a single bay bench. Here these columns are vertical and a pitch roof is provided. These are rafters. Similarly, this is a multiple bay bend. So this is a first bay, second bay, third bay. This type of structure is preferred in industrial structures. Here this is a multi-story building. These verticals are columns and horizontals are the girders or beams. This one is a portal frame. Here this is a tapered portal frame. Here this cross-sectional area is higher. At this point also external area is higher. The reason behind is that the bending moment is maximum and shear force also maximum at these points, and therefore design has to take care by providing more area. These are also called as hinged sections because these areas are increased. Similarly, this one is a knee braced truss bent. So this is a truss supported on columns, and the lower part or lower chord of the truss is connected by means of sloping braces. They are called as knee braces. This is knee braced bent. So let us learn about different structural members in an industrial building. Here this is actually a gable end of a structure. This end is called as gable end. This one here, actually a first truss is provided, second truss, third truss, and so on. So distance between these two, gable end and first truss, first bay, second bay, third bay. These are vertical columns. These horizontal small members, small beams supporting the cladding, vertical cladding or vertical sheets of infrastructure, they are called as girders. Here there is a horizontal gird which is provided at the intersection of sloping roof and vertical walls. You straight. Then these are the purlins, and purlins are kept together by means of sag rods. Sag rods actually are connecting, holding together all the purlins or preventing the purlins from going down under gravity. That means these sag rods are subjected to the tension. Then here these are called as top chord bracing, or these are called as wind bracing. So these are called as top chord bracing. These are called as vertical bracing. These are called as siding. Next, examples of steel structures. So there are, you can give many examples of steel structures like bridges, towers, multi-story buildings, storage tanks, industrial buildings, etc. So let us study different or giant steel structure already constructed. And this one, number one, is this photograph shows a bridge, Pamban railway bridge at Rameshwaram. Then this is a very famous bridge you must have observed in many Hollywood or Bollywood films, and this is a Golden Gate Bridge which is located at San Francisco in United States of America. These are the different photographs of steel structures. Number for this photograph is a Willis Sears tower. This one is a water tank, and this one is a transmission line tower. Then many of you must have seen this stadium which is located in Beijing, China, a unique and special designed stadium. So, and look at the beauty and aesthetics provided by them, and at the same time the stadium have been planned, designed to resist earthquake loads, higher earthquake loads magnitude. In a typical pre-engineered building, Kansas City, USA. Here, whenever we want to design a very large columnless space, just like indoor stadiums, indoor halls, conference halls, these type of structures are needed. This one is a Walt Disney concert hall in Los Angeles, USA. Now let us conclude the lecture by means of fabrication and erection. So here, what are different activities in the fabrication shop includes, that is number one, exact cutting of length based on the fabrication drawing, straightening of members, cambering of beams, drilling or punching of holes, welding of gusset plates, machining of butt joints, caps and bases, surface preparation such as shot blasting, painting or galvanizing after picking in acids, marking, shop assembly and erection, inspection and testing, and finally packing. Thank you very much for listening this lecture on different structural steel and their properties.